Algebraic expressions. How will you express things first? When you are happy, how will you express? You simply smile. When you are angry, how will you express? You are keeping, I think you are searching something to throw that on me to show you angry. Okay, better I am staying online, so not a problem. Then when you are sad, how will you express? You just keep your sad face. That's all. So likewise, in math also we'll express things. How we can express? Using numbers. How many numbers do we have? Many numbers. Infinite numbers. Okay. Suppose in your class, you all will be given a roll number. Is it? You all will be given a roll number. For each one of you, I'll be giving 2 chocolates more than your roll number. I'll be giving 2 chocolates more than your roll number. If your roll number is 1, how many chocolates you'll get? 1 plus 2, 3. If your roll number is 21, actually my favorite roll number is 21, 23. So what varies here? Your roll number varies. The chocolate that I am giving remains same. So that means it gives us the definition of 2 different things. One is a number which is varying accordingly, is called as variable. How do we denote a variable? The numbers alone won't be enough. We are using alphabets. Using 26 alphabets, both capital letter and small letter will use more often. Okay. So let your roll number be X. Let your roll number be X. I am offering 2 chocolates. Will it vary? You are my favorite student. I am going to give you 4 chocolates. Discrimination. Will I do? No, I won't. Whatever it is, without discrimination, 2 more chocolates. This won't vary. So this type of quantity is called as variable. Okay, variable. Is it? The 2 chocolates are constant. These 2 chocolates are constant. It won't vary. Your roll number will vary. Okay. So how will you represent the situation? The chocolates each person will get is X plus 2. This like will represent. We are expressing things. Likewise, 2 more than 5 times your roll number. Then 2 more than means plus 2, 5 times your roll number, 5x. So these kind of you are expressing things, right? These kind of expressions are called as algebraic expressions. Okay. These expressions are classified into types. First, if the power of the variable is non-negative integral power, which means the power is a whole number, then we can call that algebraic expression as polynomials. So, in an algebraic expression, there are variables, and in that variable's power is whole number. Then we can say it is a algebraic expression. Sorry, it's a polynomial. Okay. Then it is called as polynomials. Likewise, the higher powers of these variables also can be written. You see, 2x square plus 3x plus 2. This like you can write 1, or else 2 by x plus 3x square plus 7 or 2xy plus 3y square plus 7x square. We may use one or more than a variable. More than one variable may be there based on that. See, this is called as polynomial. Now, among these algebraic expressions, which are all the polynomials? All the powers of x is a whole number, not other than whole number. Yes, this is a polynomial. Is this a polynomial? Yes, powers are whole number. Yes. Is this a polynomial? Yes. Is this a polynomial? No, because 2 by x I written. That means x power minus 1. This is not a polynomial, but we can say this is a algebraic expression. This has another name called as multinomial. This is called as multinomial. An algebraic expression which is not a polynomial is called as multinomial. Okay. And this one, is this polynomial? Yes, it is polynomial. Now, we see what is term. Term, yes, constant and variable combined together is called as term. In that term, it follows the definition of a polynomial. The power of a variable which involved in the product is not, is a whole number. Then we can call the term as monomial. Okay. Term means this root 2x, x root 2, xy square, ABC also you can call it as term. But monomial, when it comes to monomial, all the powers should be whole number, not other than this. So all these terms are, these all we can call it as term. Among this term, which are all the monomials? Except this, all the other things are monomials, because the power is 1 by 2 here. Okay. Then we are going to conclude a statement that all the monomials are terms, but all the terms are need not to be monomials. We should not say not, it need not to be, not necessary that it is a monomial. Okay. Now we will come back to the definition of polynomials. Polynomial is consist of one or more than one addition subtraction of one or more than one monomials is called as polynomial. Okay. So polynomial is consist of one or more monomials. Then multinomial means what? One or more terms. One or more that is the difference between these two. So when you have one or more terms, it is a multinomial. When you have one or more monomial, it is a polynomial. Now we compare these two. All the polynomials are multinomials, but all the multinomials need not to be a polynomial. That is the basic definitions to be understood before starting multiplication of this. Okay. Now we will start with multiplication of algebraic expressions. Also, when I say, have you written everything? So when I say algebraic expression, each one of us have a different way of expressing, is it or not? When I say polynomial, but everyone has to follow the same. So then only other persons will understand. So the powers involved in the variable either be in increasing order or that should be in the decreasing order. In that manner, everyone has to express. Then only it would be understood by other persons. So the general form of the polynomial, general form or standard form, whatever you call it, there is a variable a1x plus a2x square plus and so on an x power n, and this can be represented as p of x, q of x, r of x, like we will represent things. And the leading coefficient, this an, should not be equal to 0. You know what is coefficient? Coefficient, it's like a friend who is sitting with the other person. So the coefficient of x is a1, coefficient of x square is a2 here, or we can represent like this, a0 x power n plus a1 x power n minus 1, a2 x power n minus 2. Remember, I told you increasing or decreasing power of the powers of the variable. Here, who is the leading coefficient? The bigger one coefficient. So here a0 should not be equal to 0. So these kind of algebraic expressions we are going to multiply. How we are going to multiply? Yes, simply first we will see what is monomial into monomial. You take two monomials, 2xy into 3xz. See, numbers with number, it has to be multiplied. Variables with variable, when it is a like term, like x variable can be multiplied with the x alone, not the other one. So this is one term, this is one term, this is one monomial, that is one monomial. So numbers with numbers 6, variables with variable, same way number is there means square will put, like the same variables, x into x, we have x square, y, z. That is how we should multiply two monomials. Now monomial into binomial, how do we multiply? It should be considered as two multiplication of monomials. We are multiplying with two monomials, likewise we should consider. See, monomial into binomial. Binomial means it consists two terms, 2xy into 3xz plus 7y. Likewise, we have 2, the monomial into binomial. So here, this should be considered as two things, 1, 2. So which means, first we have to multiply 2xy with 3xz, then the results will be added, 2xy into 7y. Then the resulting value is, this will be multiplied, we will get 6 x square z, and this will be multiplied 14x. That is the result of this. The same applies for any monomial into polynomial as well. If more than two terms are there means, we will multiply the monomial with each term and we add the result at last. As many terms, as many things. Next, the division of polynomials. Before getting started with the division of polynomials, there is a value of a polynomial. What would be the value of this polynomial? Look, the initial case I told you, based on your roll number, I will give you 2 chocolates. The expression we expressed using expression. This is a polynomial, p of x. Now, when your roll number is 21, the polynomial's value is that. How will you mention? So, when x is equal to 21, this p of x is there, no? P of 21. So, p of 21 is 21 plus 2. So, we have 23. It is a value of a polynomial at a particular given value. Suppose the value in which you obtained in general, we'll say if x is equal to a, f of a or p of a is the value of a polynomial at that particular point. Okay. Now the value you so obtained is 0. Suppose this f of a is 0. Then the applied value is there, right? A, x is equal to a. This is called as 0 of the polynomial. The applied value. If it is not 0, you just simply write f of e. That's all. It's a value of a polynomial at the point. If that becomes 0, the applied value, the substituted value will become 0 of a polynomial. We call it as a 0 of a polynomial. It won't become. So next, division.